The universe was once a tiny speck no bigger than an atom.
The universe has since grown to an incomprehensible size, stretching out billions and billions of light years. It is the world in which we live, and it might be the most valuable in the universe. Planet Earth, the blue marble in space. The only known place in the universe where life exists. This is the place of origin of the human race and the beginning of our journey into the cosmos. Some of the most mysterious secrets are hidden in the depths of our cosmos. The universe has hidden secrets from us. The answers to these mysteries could revolutionize our understanding and knowledge of the universe. Today, astronomers have captured images of stars, galaxies, and their collisions. The nebula clouds will help us to visualize all the possibilities. The Hubble Space Telescope has captured over 1 million images. It has been a pioneer in our exploration of the cosmos. The Kepler Space Observatory discovered more than 4,000 exoplanets. Some of these are thought to be Earth-like and capable of supporting life. These discoveries have galvanized widespread agreement among the general public that the universe is a stunning creation. Amazing wonders and mysterious phenomena. The universe continues to amaze and captivate us with its complexity and magnificence. However, one must also be aware that space exploration in the modern era is still in its early stages. It is still a mystery how life began, what the universe was like at its inception, and the ultimate fate of the universe. Our understanding of our solar system is still limited, and we know even less about the universe. Step into the unknown today as we explore some of the most bizarre cosmic mysteries. Each puzzle we solve brings us closer to understanding our place in the cosmos. With each step, we're getting closer to uncovering the greatest cosmic secrets. The Dark Horse Planet. Some may find it puzzling that despite our ability to detect exoplanets at astronomical distances, some of which are hundreds or thousands of light years away from us, there is no evidence to support the existence of Planet 9. For the uninitiated, Planet 9 is a hypothetical massive celestial object that some scientists believe exists in the outermost region of our solar system. The planet is believed to have a mass between 5–10 times that of Earth's and an orbit up to 20 times longer than Neptune's, the furthest known planet from the Sun. The hypothesis of Planet 9's existence came about due to observations of certain objects in the outer reaches of the solar system, such as trans-Neptunian objects and sednoids, that have orbits that cannot be explained by the gravitational influence of the known planets alone. Therefore, scientists propose that a yet-to-be-discovered massive planet may be responsible for these anomalies, exerting its gravity on these objects' motion. If this hypothesis is correct, then Planet 9 would have an egg-shaped, extremely elongated orbit that completes one rotation around the Sun every 10,000 to 20,000 years. Compared to Neptune's orbit, which is a mere 165 years long and 8 billion miles away from the Sun, Planet 9 would appear incredibly dim, about 6 million, 250,000 times fainter than Uranus from Earth. Although asteroids are all dim, their rapid movement across the sky makes them distinguishable. Planet 9, on the other hand, would have a relative speed that is very low compared to Earth. It would be difficult to distinguish it from just another dim star. One approach would be to use advanced telescopes such as the Kepler telescope to locate Planet 9. However, telescopes do not work in this way. Telescopes detect exoplanets by observing small eclipses when the exoplanets pass in front of their stars. If it does exist, Planet 9 won't be able to do that. Scientists would need to search for it in the midst of space's darkness, detected by measuring how much sunlight it reflects. This task is like searching for a needle in a haystack, except the haystack is in space and you're looking for a pea-sized needle. To make it more difficult, you have to spin around like a top while you do it. It begs the question, how do we go about finding Planet 9? Even if I showed you this image, you might be able to spot a planet and say, yes, that's Earth there, but it may not be so easy in practice. You might have already guessed what challenges scientists face. It is therefore truly amazing that the first human astronomers, using nothing but careful observation, were able to distinguish between stars and planets over 4 millennia ago. By observing and recording the night skies on a regular schedule, Babylonian astronomers charted the movements of stars using intricately detailed star charts and identified the orbits of all celestial bodies within our solar system. The stars, being at such a distance, shouldn't appear to move in contrast with the planets, which are much closer. It's quite an astute deduction. This method, with today's technology, can only detect planets closer to Earth. Infrared telescopes were used to try and detect Planet 9's heat signature, but the search was unsuccessful. Scientists pose a logical problem. What type of object could have enough mass to alter the orbits of celestial bodies, but still remain invisible to us? Planet 9 could be a misidentification of a primordial black hole, which would have similar effects. It's purely hypothetical, as we haven't yet detected a primordial black hole. At the dawn of time, everything was hotter and denser. Black holes appeared and disappeared within a single second. Depending on when such a black hole was created, its mass could have been as small as 5–10 grams, or as large as 100,000 solar masses. If our calculations of the elusive planet's mass are correct, then a primordial black hole with a mass a few hundred times that of Earth would be no bigger than a grapefruit or even a fist. If that's true, then we will never be able to find it using a telescope. We should also remember that black holes are infamous for their gravitational pull. They are among the most destructive celestial objects in the universe. Even light cannot escape their gravitational pull. However, if there is a primordial black hole at the edge of the solar system, there is no need to be alarmed. The Earth is not at risk. Primordial black holes in our solar system would be too small to pose any real harm. What led astronomers to think of primordial black holes? It was a strange, inexplicable brightness of stars, as if a massive force had passed in front of them. These stars started to shine brighter, and not just for a moment. They also appeared curved, as if you were looking through a magnifying glass. Scientists created a computer simulation of a black hole that was 5–10 times heavier than Earth and had an orbital distance from the Sun. The results were strikingly similar to what is happening in the Kuiper Belt region. This is too much to be a coincidence. A primordial black hole could explain why the hypothetical planet 9 is not visible and does not emit infrared radiation. Another wild theory is that planet 9 might be a brown dwarf, a star not massive enough to support nuclear fusion at its core, but still capable of emitting light. The possibilities are limitless. Perhaps there is an image of Planet 9 out there that was mistakenly identified as an existing object. It's understandable that it might take a few more years to realize that a star isn't exactly where it was when it was first observed. The Vera Rubin telescope, which is being built in Chile, is part of the new generation of instruments expected to help find Planet 9. It is part of the Legacy Survey of Space and Time project and will begin operations in 2023. The telescope will be 4 meters or 5 feet in length, with a camera of 3,200 megapixels. The camera, which is the size of a car, will be the largest ever constructed for astronomical use. This tool would allow scientists to not only confirm if Planet 9 exists, but also discover up to 20 terabytes of space objects and other phenomena in just one night. In just 1 year, the observatory can capture more of the universe than all the telescopes on Earth combined. It can change our perspective on the universe and our place within it. The James Webb Telescope offers unprecedented detail of the infrared area of the universe. It's a challenging task. It's a tedious task. Planet 9 may not exist at all. While the jury is out on what exactly is out there, we know that, with the advances in technology and the dedication of astronomers around the globe, someday we will solve this mystery. First contact. Lost in the noise. Extraterrestrial life is a topic of intense discussion whenever the mysteries of the cosmos are brought up. Despite efforts to scan the stars for signs of life beyond Earth, what have we learned? In 2022, a telescope in China recorded an anomalous signal, which exhibited a very restricted frequency range of 140–604 megahertz. This level of accuracy is not typically achieved through natural means. The signal sparked a wide-ranging investigation into its origins. It was immediately hypothesized that the source of the signal came from the general area of Kepler 438b, which is located about 470 light-years from Earth. Kepler 438b is a planet that fits into the known class of planets with a radius of just 1. 5 times Earth's, known as super-Earths. Its location within its host star's habitable zone suggests that liquid water may exist on the planet's surface, creating a suitable environment for life to emerge and thrive. Therefore, Kepler 438b is a top choice for astrobiology studies and a potential candidate for the search of alien civilizations. The 500-meter aperture spherical telescope, nicknamed Sky Eye, located in Guizhou province of southwest China, intercepted the potential transmission. The telescope was designed with SETI, Search for Extraterrestrial Intelligence, in mind. It's unsurprising that the telescope, with a diameter of 1,600 feet or 500 meters, has the capability to capture 40 billion observations every second. The telescope is a marvel of engineering with its vast size and unmatched sensitivity. Chinese authorities immediately the Kepler 438b signal was of extraterrestrial origin and represented an alien intelligence. China's Ministry of Science and Technology reported that its astronomers discovered several examples of possible technological signatures indicative of extraterrestrial civilizations beyond Earth. These claims spread rapidly, first in the Chinese state-controlled media, then on Weibo and other social media platforms, before reaching international media. The story then mysteriously disappeared. The report vanished without explanation, as though the document had never been created. The international astronomy community proposed a number of theories, the most common being radio interference. Dr. Wertheimer of the University of California, a prominent SETI researcher, refuted the claims. He said the signals are merely radio emissions generated by Earth-based sources and do not provide conclusive evidence of extraterrestrial life forms. Radio interference is a growing issue. This is due to the exponential growth of electronic devices in the human population and the increasing number of satellites in Earth's orbit. This leads to significant discrepancies in instrument readings. It is thus crucial to carefully verify and filter these interferences before drawing any conclusions. This situation is common and has led to numerous false positives in the past, leading to a growing skepticism among scientists regarding these signals. Even world-renowned American astrophysicists, such as Dr. James Lovelock and Dr. Frank Drake, known for his famous Drake equation, have been misled. In 1960, Dr. Drake captured a strange signal using a radio telescope. He thought he had made a revolutionary discovery when he saw a pair of stars, only to realize later that the signal was a stray antenna emission. In 2019, astronomers in southeastern Australia detected a signal beaming toward Earth from Proxima Centauri, the closest star system to our Sun, at a distance of 2 light-years. It is believed to have at least one habitable planet. The Breakthrough Listen team conducted a 26-hour survey as part of a $100 million global effort to use telescopes to detect alien transmissions. The researchers picked up a 5-hour-long burst of radio waves. Out of the 4 million signals that they recorded, Bucone was unusual for both its duration and wavelength. After eliminating the possibility of satellite interference, the team proceeded to eliminate other possible sources. The signal was also detected in other human-made crafts, but its ultimate origin remained a mystery. The researchers didn't realize how much they had overlooked until a few years later when they reanalyzed their data. They discovered this time that their automated sorting system had overlooked signals that looked strikingly similar to Bacone. Bacone and the look-alike signals were likely components of the same source of radio waves, which likely came from the Earth's surface and was probably within a few hundred miles of the Australian telescope. The signal did not reappear, suggesting that the source was malfunctioning equipment that was either deactivated or under maintenance. The team speculated that the signal occurred due to maintenance activities coinciding with the 5-hour observation period during which Proxima Centauri was in view. This isn't the first time a piece of mundane human technology has been mistaken for alien equipment. Another famous set of signals, once thought to be generated by extraterrestrial entities and detected between 2011 and 2014, was later determined to be produced by scientists heating their meals in a microwave. SETI is a difficult business. You have to sift through a lot of noise to find the true signals. Scientists have often contemplated the idea of building a telescope on the far side of the moon as a way to bypass Earth's growing radio pollution and interference from orbiting satellites. It's perfectly natural to feel a touch of skepticism when you hear about a new alien signal being detected. We've all been fooled before by false alarms. But that's how science works. Keep an open mind and never cease exploring. Even if that means sifting through many false leads. Maybe one day, we'll discover the undeniable evidence proving that we're not alone in this universe. A century ago, the sky was pristine, but the technology needed to exploit it was not available. As we look forward, we can see how technology has changed. The sky could soon be filled with so much human-made noise that the opportunity to enjoy this view may no longer exist. The present moment could be an opportune time to conduct the search for extraterrestrial intelligence on Earth. Many experts in CT believe that we're on the brink of a breakthrough. New technologies allow us to scan more stars with greater precision and accuracy. This new optimistic SETI mindset has revitalized the search for extraterrestrial life. Despite the long-standing paradox between the abundance of possibilities in the cosmos and the lack of tangible evidence of life beyond our planet, the life of the universe inspires renewed optimism. The apparent contradiction is a result of the age and vastness of the universe. The Fermi paradox, or the lack of evidence for intelligent life beyond Earth, has long been a source of consternation for scientists. The paradox is named after Enrico Fermi's impromptu lunchtime musings. After pondering the conundrum, he famously exclaimed, "So, where is everybody?" Scientists believe that the lack of aliens in our galaxy is normal because only a small fraction has been explored. Only a tiny percentage of the Milky Way's 200 billion stars have been studied. One of the key aspects of detecting extraterrestrial radio waves is to detect their signals. SETI's main methods are a daunting task that requires advanced technology and the latest scientific methods. It was never going to be an easy task. It's not just about the technology, but also the approach. Conversely, some scientists argue that it might be necessary to rethink methods. Consider the alternative communication methods that extraterrestrial civilizations might use. We may also be missing signals sent by alien civilizations, either intentionally or unintentionally. Signals that are leaking across the vast expanses of the cosmos may not be encoded in radio waves, but rather in ways our technology isn't yet advanced enough to understand. Our current approach to SETI may be misguided. If you look back to the early days of SETI, some of the first ideas were to build large fires or install big mirrors to reflect sunlight for the Martians, or even to make long right-angled triangles to demonstrate our knowledge of the Pythagorean theorem to aliens. Today, we say that those ideas were naive. Who's to say that people 200 years from now won't ask us why we didn't use subspace communication or tachyons? But for now, we are limited by the knowledge and technology that is available. Despite this, SETI astronomers remain resolute, holding onto their belief that humans aren't the only ones in the universe. With an estimated 1 trillion planets within our galaxy, many of them similar in size and composition to Earth, the potential for intelligent life to exist is high. They remain hopeful that one day, among all the radio noise we create, we'll discover something truly remarkable. While it may take time for the first contact to occur, it is only a matter of time. Beyond the cosmic horizon is one of today's most debated topics in the scientific community. How vast is the universe? The vastness of the night sky serves as a reminder of our insignificance. The stars that twinkle above us silently underscore the smallness of our home planet. Just a glance at the sky above can give you a sense of the enormity of the universe. It is beyond our comprehension. The mystery may never be unraveled, and the puzzle might remain unsolved for all time. Despite the vastness of the question, it continues to stir human curiosity. You're not alone if you've ever asked, where does the universe end? This question has been on the minds of many physicists for years, including Stephen Hawking, who passed away in 2011. Albert Einstein's revolutionary 1917 prediction of the expansion and growth of the universe was initially met with skepticism until evidence was provided by Hubble and Humason. In his general theory of relativity, he posited that the fabric of space itself was expanding. This causes galaxies to move apart. A photon emitted by a distant star travels through a continually expanding universe, increasing the distance it must cover before reaching us. Just how big has the universe grown since the Big Bang? Measurements from the Hubble Space Telescope and other instruments estimate that the universe is about 13.8 billion years old. A beam of light would have traveled approximately 1.3 quadrillion kilometers or 13.8 billion light years in this time. The Hubble telescope has observed galaxies that are 46.5 billion light years away in both directions, making them 93 billion light years apart. But is this the true size of the universe? To accurately determine its size, it's essential to understand the shape of an object. Researchers have debated and discussed the shape of the universe for years, but there is still no conclusive answer. According to Einstein's theory of relativity, time and space can bend, meaning space can take on a variety of forms. This is difficult to envision in 3 dimensions, as we perceive space. So let's use a 2-dimensional example instead. In flat regions of space-time, objects moving along parallel paths remain on those paths. In positively curved space-time regions, parallel paths diverge while they converge in negatively curved space-time regions. So what about space in its entirety? If space were positively curved in all directions, then it would resemble a colossal sphere. In theory, if you kept walking, you could eventually return to your starting point. If space were flat, it could have a straightforward shape, extending straight out to infinity. If space were negatively curved, objects would fall rather than fly. So, which is it? The curvature can be determined using the angles of a triangle. On a flat surface, the sum will equal 180 degrees. If the surface is curved, the sum of the angles could be more or less than 180 degrees depending on the degree of curvature. The Planck Observatory has done what cosmologists do when they measure the size of our universe. They find triangles by studying the spatial relationships between points in a snapshot of the early universe. What did the data from Planck and other experiments reveal? The measurements indicate that the universe is almost entirely flat, with a margin of error of 0.4%. So, can we conclude that the universe is infinite and flat? Physics is a science based on experimentation. What we mean is that the measurements are consistent with the universe being flat, but the measurement also allows for a small degree of curvature. If we stand on a beach and look out to the horizon, it certainly appears flat. But despite what some might claim, the Earth is not flat, it is spherical. We must keep this in mind. What appears flat may indeed be curved. When we measure the Earth, we can only conclude that it appears flat. The same holds true for space. The space appears to be flat. But just like the Earth, our universe could still be curved on a larger scale. This is an intriguing concept that challenges our understanding of the cosmos. There's much we don't know, and that's part of the excitement of studying the universe. Here are the corrections to the provided subtitles. What if space were a huge sphere that only appeared flat? Just as the Earth may appear flat, so can space. In that case, space isn't infinite. It is finite in size. During analysis, the maximum curvature permitted by the best estimates, astronomers have found that the universe cannot be smaller than 250 times the visible universe. That's 93 billion light-years multiplied by 250 to get 23 trillion light-years. Or, to put it another way, the entire universe is to the observable universe as the Sun represents the United States. Does that mean there's an edge to the universe? What lies beyond the edge if it exists? As far as astronomers are able to tell, the universe may or may not have an edge. What we see is only a small part of the visible universe. A spotlight that shines from your position, but only illuminates the edges of what you can see. A vast area of space, 93 billion light-years in size and constantly expanding. We can observe this from Earth with powerful telescopes. We can see galaxies that are millions of light-years away in this circle. We are not observing the world as it is today, but as it was many millions of years ago. The farther we look, the further back in time we see. We encounter the first light, which occurred only a few 100,000 years after the Big Bang. The cosmic microwave background is the furthest point of the universe we can see from Earth. Yes, it is possible that the universe is infinitely large. In that case, calculating its size is pointless. An infinite object cannot be given a shape because it lacks boundary points for calculations. The beauty and majesty of this infinite expanse are beyond our comprehension. Imagine endless galaxies and stars, each unique, full of secrets and wonders. They stretch out to infinity. The fact that the universe continues to expand, creating new space and possibilities for the near future, adds to its magic. The infinite universe is a fascinating theory, whether you're an astronomer or philosopher. This will continue to capture the imagination of future generations. It serves as a gentle reminder that, amidst our hectic daily lives, we remain a small speck within the vast expanses of the universe. The next time you gaze up at the night skies and notice the twinkling stars in the distance, remember that you're just a tiny spark in a grand cosmic drama. Enjoy the beauty and mystery of the universe. In that infinite space, we find our true place. We're going to embark on an amazing journey into the depths of the universe. Starting with Earth. The Odyssey begins with Earth's birthplace as we zoom out. A unique planet, as it is the only celestial object in the universe known to harbor life. It is home to millions of species. However, no species has altered its appearance as much as humans. The impact of human civilization is visible from this height. Our man-made structures such as highways and agricultural fields will likely remain for millennia, if we are fortunate. As we ascend, we begin to lose sight of our identity and the things we have created. From this perspective, it's difficult to tell that we have ever existed. This solitary blue sphere is the foundation of our entire history. It's a place where billions have lived and died, and will continue to do so. This is where humanity began. This is the world that we all came from. We must now leave all this behind and travel farther than any human has ever traveled, because our destination is quite literally the edge of the universe. Our first stop is the Moon. It's the closest celestial object to us and the only celestial body on which humans have set foot. We then cross the orbits of other planets as we move toward the infinite void of interstellar space. Our Sun, the star that warms our oceans, stirs our atmosphere and provides the energy that allows plants to generate the oxygen we breathe, is just one among billions.
The stars in our night sky are now visible in all their vibrant glory.
Unfiltered by Earth's atmosphere. Like bright, colorful dots on a black canvas. The Milky Way galaxy is our home, but some stars shine incredibly bright. Some exoplanets may have the right conditions to harbor life. We cannot stop to explore these alien planets because we still have a long way to go. The Milky Way is a vast expanse of gas, dust, and stars. It spans an area of 100,000 light-years. Within its bulge, there's a beast, a supermassive black hole. We can see the vastness of our galaxy from this point. Despite its size, this galaxy is only a tiny droplet in the vast ocean of galaxies in the visible universe. Each of these bright points represents a different galaxy. The Milky Way is now a faint speck in the distance, but most of these galaxies are filled with billions of celestial objects, as well as clouds of dust and gas. Most of these galaxies, like the Milky Way, which is now a faint dot in the distance, harbor a supermassive black hole at their center. Some of them are merging in a cosmic gravitational dance. The universe's matter is not evenly distributed. There are voids between dense clusters that are connected by a beautiful cosmic web.
This is a small glimpse of our observable universe.
It's a page from a tome that dates back 13.8 billion years. The journey shows us the vastness of the universe and how minuscule our planet is in comparison. This is where we are. You might even find yourself questioning your existence and purpose. Honestly, our knowledge is very limited, and there is so much we don't know. Our ability to contemplate and embrace the infinite possibilities in the universe is curtailed by the illusion that we have all the answers. It is awe-inspiring that, as a tiny speck floating aimlessly through the vastness of space on a speck of dirt, we can see so deeply into the universe. Yet, our understanding is still limited, and we are far from comprehending the causes of the events in the universe. The next time you find yourself in a situation that is not going your way, go with the flow. Resisting the universe is pointless. It's not necessary to have all the answers in life. Instead, embrace and savor each moment it comes. We are not just individuals. We are a part of the entire universe. We often feel very separate from the world because our perspective is limited. Consider this. Over billions of years, the universe changed and evolved to create us. You were literally made from star material. We're the result of billions and billions of years of evolution and change in the universe. We're tiny, but everything else in the universe is also special. The universe, this whole universe, including you, is guided by a single universal consciousness or intelligence. Our limited minds often make us feel isolated. Neil deGrasse Tyson famously said, "We are all biologically connected, chemically to the Earth, and atomically to the rest of the universe." We are not only in the universe, but the universe is also in us. We are the universe, and it is our responsibility to treat one another with dignity, love, and respect. I believe we can thrive as a species, and even as a planet. The question of what lies outside our observable world can wait until then, and will remain one of history's greatest mysteries. We are only scratching the surface of what we know. The surface of the universe is just the beginning. As we reach the end of our journey, it's almost impossible not to experience an existential crisis when you are exploring the secrets of the universe. However, this realization should not depress us, but rather inspire us. Keep searching for answers and expanding our understanding of the universe. The pursuit of knowledge is what makes us human, and our quest to unlock the secrets of the universe is a testament to our insatiable curiosity. As we close this chapter, let's not forget about the endless possibilities and wonders waiting to be discovered beyond our reach. We are just a small part of the universe's story. We must embrace the unknown and never stop exploring or searching for answers. The greatest secrets of the universe still await discovery.